everyone. In this short video tutorial, I'm going to demonstrate how to use SPSS in analyzing one sample t-test or in running the one sample t-test, as you may call it. So, based on this short video demonstration, I'm going to use a kind of data set that contains information on newborn babies and their parents. So essentially, it consists of continuous variables. So in this data set, you have variables like the baby number, the length of the baby, the weight of the baby in kilogram, the circumference, the head circumference of the new baby, the gestation weeks, and the smoker, whether uh, mother smokes, which is one for smoker, and two for non-smoker, or we could say one for smoker and zero for non-smoker, as the case may be. Depends on the value that you would like to use. Then we have the maternity age, then the father's age, which uh, we believe is going to impart on the weight of the newborn baby. Then you have the father's years in education, the number of cigarettes smoked per day per father, then the father's height, as well as the the data, the variable I mean, for the birth weight. Then you have zero for low birth rate and one for yes. So invariably, what we are talking about, this is a dichotomous variable, whereby if when you determine the birth rate, if it is low, you say yes, and if it is not low, you say no. So we assign a value of zero to no and one to yes. Then you have as well the the age of the mother, right? Which is dichotomous as well, whether over 45 or not, or below 45, yes or no. Right. Now, for us to see clearly what I'm talking about, let's go to SPSS. Right. Let me see if it has been opened. Not yet. Okay. Yeah. So essentially, this is what I've just talked about in terms of the variables. As you do know, in SPSS, a window of this nature is called the data editor window. So below the data editor window, you have two icons, which provides you the means of visualizing whichever variable or whichever window or whichever side of the data that you want to see. For example, if you want to put in focus the data view, then you click on the icon for the data view. Then you can be able to see the spread of the data. Then if you want to see the variable view, then you click on the icon, which is variable view, and then you'll be able to see the various variables that are involved in the data set. So, as I've explained before, you got how many variables you have here? You have up to 16 variables. right? Ranging from the baby ID to the through the head circumference. Then you have let me put it so that we can see it more clearly. Then you have the length of the baby, as I've already explained. So essentially, these are the variables. Here we can say smokers. It's a variable here. So given the specificity of this variable, it's a categorical variable, as you could see here. Categorically, in the sense that uh, you have the values attached to the variables. You have zero for no smoker and one for smokers, right? As I've already explained. Then you have another variable here, which is categorical as well, the birth weight of the baby. So, given the nature of this variable is dichotomous, right? If no low birth weight, which is no zero, then if it is yes, low birth weight, then a value of one is assigned to it. Then you have the age of the mother as well, uh, less than 35, zero, value attached, and more than 35, one value is assigned to such a category. So, yeah, that is for that. So, what we need to do now is this. Uh, this data set consists of mothers, small mothers that are smoking and mothers that do not smoke, or mothers that are not smoking. We have no smoker and smokers, in short. So, what we do need to do now is, given the fact that we are more interested in the birth rate of babies born to smoking mothers. So we need to select the cases so that we can be able to work on the cases that are related to smoking mothers. So how do we do that in SPSS? It's very easy. So what you need to do is here we click on the data, then we scroll down, then to the select cases icon. So then the window of this nature will pop up. So what we need to do is, in this case, we are not interested in all the cases. So we are interested in the selected cases. So what we need to do is to click this icon. It says if condition is satisfied. Then click on it. Then let's be mindful that what we are working on or what we are interested is the birth weight. So what we need to do is we need to move this birth weight, right? So we are interested in, right, the smoking model, sorry to say, right? Then you um, move the variable for the smoker to the box. Then you need to select the case for the smoking border. Remember, the value that was attached to the smoking border is 1. Then you say equals 1. Then you click OK. Now, what you need to do is we need to copy the selected cases to a new data set. We don't want to mess up with the old data set. We want to create this data set for smoking borders. So what you need to do to be able to achieve that operations, you click on copy selected cases to a new data set. Then we can say name this data set now to be smoking bonus. We are putting this underscore so that it will be acceptable because for you to be able to label a variable got its own rules. For example, you cannot you cannot space anything. You cannot put a space between the two words. So yes, that has been done. Then you click OK. So as you could see here, a new data set has been created. Look at it. If you check, remember here is the title bar, right? You could see here, this is smoking bonus compared to the one that we've had previously. Let's see. You see the title, birth weight, one simple t-test, right? SAV, right? You see, the data set we have been created is exclusively for smoking mothers. You could see it here. It's appearing here. So that means we've done the right thing. Now, we need to work on this data for smoking mothers so that we can be able to achieve our objectives in terms of what we want to achieve. Now, what we need to do now is this. Having done this, having selected the cases for the smoking model, then we need to carry out our analysis. The first thing we need to do is to explore the data. So, how do you do that? You click on the icon Analyze, then you go down to Descriptive Statistics, then down to Explore. There you have a window that is pop up like this, a small window of this nature. Then what are we interested in? We are interested in the birth weight. Then you click on the birth weight, you move it to the dependent list box. Now we need to specify, define exactly, set certain parameters in terms of what we truly to achieve here, right? Now, for the level of confidence, let's leave it at 95% confidence, right? We leave it at 95% confidence, right? Our estimate, then we say continue, right? The plot, we are going to uh, specify how we want or uh, how we want the plot to be and what exactly we are interested in. Or yeah, for example, in this case, we're interested in the histogram. We want to see that how the distribution looks like in terms of being able to determine whether there is that level of normality. Then we click on this, which is the normality plot with test data. There you say continue. Right. So now we click OK. Right. So yeah, depth it will bring out the output window. So let's see what the output window it is. So first of all, let's look at the case processing summary. 22 cases were involved, 100%, and there was no missing cases. zero, 0%. So the total number is 22 and it's 100%. Right. That's good. Now, let's look at the descriptive statistics. Here we've got the mean. The mean says 3.1341. Then you have the median 3.1850. So as you could see here, the mean is noted so much far away from the median. That means the difference between the mean and the median, they are more or less the same. Then you have the variance, the standard deviation. Then you have the minimum, which is 1.92, the maximum 4.57. Then you have the range. You have the skewness here in terms of the distribution, whether it's positively skewed to the right or negatively skewed. Then you have the contrasts, which measure the tail of the distribution in terms of establishing whether there are outliers. Then let's look at the test of normality. We have two type of tests. You have Shapiro-Wilk and Kolmogorov spin-off. So Shapiro-Wilk normally is used to test few data or data that is less than 50. Whereas if you have larger data, you can use a Kolmogorov spin-off to carry out test of normality. So now let's try to interpret the data now. So the level of significance here is 0.949, which is very high. Remember, our level of confidence was 95%. So the p-value is uh, 0.05. So if the level of significant, if this significant value here is fall within the range of, let's say, 0.5 or less than 0.5, then we can reject the null hypothesis. Assuming in this case here that the null hypothesis is that there is a normal distribution. So in this case, it's more than 0.05, the level of the significant level here. So what we can say is we cannot reject the null hypothesis. That means there is a normal distribution. So then let's look at the histogram. Look at the histogram, the way it appears. It's not, it appears to be symmetry, close to normal distribution. Then you have the tree, the stem and leaf plot. The stem and leaf plot, you have the stem, this is the stem, then you have the leaf, right? So another important thing we need to take cognizance of is the normal QQ plot of birth weight. As you could see here, the values are not they forming a straight line. They rarely run closely along this straight line, which is a sign of normal distribution. If the distribution was to be not normal, or if there were outliers, then you would see them scattering around without uh, being able to form a well-defined straight line. So, yeah, that is how to interpret that. Then let's look at the box, right? Let's look at the box, right? When you look at the these whiskers, right? If it is normally distributed, the whiskers on the right and on the distance between the box, right, the whiskers here, the distance here will be more or less like the one on the right. So the distance between the box on the end here will be the same, more or less the same. But as you could see here, it's more or less the same. When you see this line, which is the median, it's fairly at the middle, at the center, which shows that the distribution is uh, normal, as you could see by this box chart. Then, yeah, that is for that. So the next stage now is for us to do our hypothesis testing. So what we need to do is we need to hypothesize. For example, suppose we believe that smoking affects the weight of newborn babies. We hypothesize that the average weight of babies at birth is 3.4 kilogram. So we are going to base our hypothesis on this. The null hypothesis will be the birth weight of babies born to smoking mothers is 3.4 kilogram. So we are going to run our analysis and see one sample test to see whether uh, we need to accept our null hypothesis or reject our null hypothesis based on our p-values that will be calculated. So what we need to do next is to carry out the analysis. So how do you do that? You click on the icon analysis, then you click go down to the compare me, then you click on one sample t-test. Here we go. Remember, what we are interested in is the birth rate, right? So you click on the birth rate, you move it over. Then remember our hypothesizer weight, which is 3.4. This is our null hypothesis that the average birth weight of babies born to smoking mother is 3.4. We want to see based on our statistical result whether to accept the null hypothesis or to reject the null hypothesis. Right? Okay. Uh, we need to establish a certain level of confidence because this is what we are going to use to compare what we call the p-value. Right. Then our level of confidence interval here is, let's leave it at 95%. That means we are 95% sure that the birth weight of babies born to smoking mother is 3.4 kilogram. So that is our confidence level, 95% sure. So let's see if we need to accept the null hypothesis with 95% level of confidence or reject the null hypothesis. Then we click here, right? Then the next thing is to click here. Okay, now we've done that. Here we have the result. These are the results. Okay. Let's start from here. You see the t-test. One sample statistics. This is the mean, the calculated mean. Remember, we said the average birth weight is 3.4 kilogram. That was our hypothesis. But let's see if we need to reject or to accept the null hypothesis based on the statistical data before us. Now, t-test value. Look at it. That this is our hypothesis value, hypothesis figure, 3.4. 4 as it is written here, test value. Now, let's try to interpret these statistics to see whether to accept or to reject. Now, for remember, we need to use the p-value as our uh, point of as a basis, as a yardstick for determining whether to accept the null hypothesis or to reject based on the level of confidence. So our level of confidence was 95%, right? That means uh, 95% confidence level of confidence. So if our p-value is equals 0.5 or less than 0.5, that means we need to reject the null hypothesis that the birth weight, or rather the average birth weight of babies born to smoking mothers is 3.4. So let's see how it works, and let's see whether we need to accept that hypothesis or reject the hypothesis. Now let's look at the p-value here for one-sided. This 0.031, which is less than 0.05. So what does this one tell us? It means that we need to reject the null hypothesis, right? So rejecting the null hypothesis means that the average birth weight of babies born to smoking mothers is not 3.4 kilogram. So in a nutshell, this is how to do one sample t-test in SPSS. Thanks for watching my video.